In this lesson, we will cover Unit 3, Section 4.3, Mixed and Entire Radicals. In this lesson, you will learn how to express an entire radical as a mixed radical and how to convert between a mixed radical and an entire radical. First, we need to look at some new terminology. First, an entire radical. An entire radical is a radical expressed in the form the square root of x, the cube root of x, the fourth root of x, and so on. For an example, the square root of 80. Next, we have a mixed radical. This is a radical expressed in the form of a and the nth root of x, very similar to 2 and the cube root of 3. An entire radical has not been simplified and is left with the whole number underneath the radical symbol. However, a mixed radical is the entire radical simplified. We will look very shortly at how to go from an entire radical to a mixed radical and a mixed radical to an entire radical. But first, we need to have a good review of our perfect squares and our perfect cubes. Perfect squares will be required to simplify an entire radical that involves a square root. The perfect cubes will be used to simplify a radical with a cube root. Now, first, a perfect square. This was introduced back in grade 9. Perfect square is a number that is multiplied by itself twice. For an example, 1 times 1, 2 times 2, 3 times 3, 4 times 4, and the list continues. This produces our perfect squares of 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. A perfect cube is a number multiplied by itself 3 times. For example, 2 times 2 times 2. Perfect cubes are 1, 8, 27, 64, 125, 216, and 343. Of course, this continues on as we go through the numbers. Here's a good opportunity to write down the perfect squares and the perfect cubes in your exercise and keep them close for a reference. Well, how do we go from an entire radical to a mixed radical? First, find the largest perfect square or perfect cube that is a factor of the radicand, which is a number underneath the radical symbol. Next, rewrite the radicand as a product of its largest square or cube and the another number. Third, take the square root of the perfect square or the cube root of the perfect cube, and then write the answer as a mixed radical. As can be seen from the square root of 80 and the cube root of 80, it doesn't matter if you have a square root or a cube root, the process is very similar. Find the largest perfect square that can be divided evenly into the number or the radicand. So 16 times 5 gives us 80. Then you take your two numbers underneath your radical, split them up into each individual radicals. Then you simplify the perfect square or the perfect cube, leaving the number that you cannot simplify, so the radicand you cannot simplify, stays as a radical. The process is the same for the cube root of 80. However, when we want to go from a mixed radical to an entire radical, the process is different. First, you're going to square the number outside of the radical if the index is 2. Cube the number outside if the index is 3. Then you're going to write that answer under the radical sign. Second, multiply the two numbers together and write the answer under the radical sign, as can be seen by 2 and a square root of 3. The index is not shown, but when we have a square root, we know that the index is 2. So the number in the front, 2, has to be squared and then multiplied by 3. 2 squared is 4 times 3 gives us 12. Second, we have 2 and the cube root of 3. The index is 3, therefore 2 has to be rose to the exponent of 3. 2 to the exponent of 3 times 3 will give us the cube root of 24. Now, in summary, keep in mind that we're going to be using an index with a maximum of 5. When you want to simplify an entire radical, you're going to factor out the greatest perfect square or the greatest perfect cube, and so on. That is your first step. A mixed radical is equivalent to the entire radical. So if you had to take the mixed radical and multiply in the number that's in front of your radical, it would show that that number or that radical is equivalent to the entire radical. Entire radicals may be used for ordering radicals from least to greatest. Keeping in mind, this section cannot be completed if you do not remember your perfect squares and your perfect cubes. However, they can be found quite easily. Keeping those numbers as a reference guide will help you along in this section.